Well, good afternoon, everyone. I'm really happy to be here. I'm based in Amsterdam, so it's a beautiful morning today, quite a sunny morning. And the title of this talk is Automatic Speech Recognition at Scale using Tensorflow, Kubernetes and Airflow, right? So first of all, I'd like to thank the organizers of our Flow Summit for having me. I've always watched the event, so it's quite exciting to be part of it this year. And well, let's get started. Just a quick recap on what we will talk about today. We'll talk a bit about automatic speech recognition, why it's important, data-centric AI, and task orchestration, of course, Airflow, Kubernetes, and Kubernetes Pod operator, MLOps, and how all these things tie together. We won't talk about machine learning model training because I'm conscious of time and it's quite a complex and fascinating topic. But yeah, we will detail how these components, how we use these components to fit together a really nice solution for speech recognition, right? So starting with a quick introduction, Sumit already gave a recap. So I'm Rafael, I'm a solutions architect at Databricks. I have around 15 years experience in technology in data-intensive industries. I'm quite passionate about machine learning, data engineering, MLOps, and Call of Duty. Let's go with the business context, right? What kind of problem we were trying to solve here? So we're talking about a top European bank. This bank has around 38 million customers globally, right? So what is the outcome of this? What is the result of this? Well, you would imagine that with this amount of customers, you have millions of customers calling client service per year. For example, if you lose your credit card, if your account balance, you think it's not right, more often than not, you would want to call your bank, right, and see what's going on. And on the bank side, they need to have a team to deal with these questions, right? A huge customer service team needs to be available so that these questions can be answered. And this means a lot of overhead and a lot of complexity. You need to have really a good setup and lots of people to be able to deal with that. So this is where our business context starts. And if we think about customer service currently in a classical fashion, right? You have all these people taking phone calls and asking questions to the client, trying to solve the client's problems. If we think about how these telephone centrals started, what we have today is not that different, right? From what you see in this picture. You still need to have a lot of people to deal with these tasks. It's highly intensive. You're not able to scale a lot because one person is able to talk only to another person at the same time. So it becomes kind of a limitation, right? And in the end of the day, the objective here is to provide the best experience to the client. And it's quite challenging to do with this type of setting. So how do we solve this, and what is the motivation to solve this problem, right? How do we use technology to provide the best possible customer service, to understand our customers, to be able to offer not only the best service, but the best products to them? So some quotes to get inspired. The guy in this picture, I'm pretty sure a lot of people know him. This guy is Sir Richard Branson, head of the Virgin Group, Virgin Airlines, Virgin Media, and many other companies. He built an empire, and this quote from him is quite interesting, right? He believes that success comes from listening to your customer. So if we think about it, we already started on a good path because in the case of this bank, there is already a client service team. We are already listening to our customer, right? But how do we do this at scale? We are already adhering to this principle from Richard, but how to do that at scale? I think the next guy has some interesting quote that will benefit us. So this guy here in this picture is Andrew Ng. Many people might know him as well. He is the creator of Coursera, and he is a quite famous researcher from University of Stanford in the field of AI. And the guy basically sets what's the trend and what's the northern star for artificial intelligence and machine learning, right? And he says that data is the new electricity. I think this phrase might sound quite simple, but if we dig a bit deeper, this means that we are moving from model-centric AI, where you spend a lot of time training models and lots of researchers finding the best model. We are shifting from this to data-centric AI, where we are worried, we are concerned with having the best data. And this also means that we are concerned with the best way to productionize our machine learning models. So a bit of a digression here, but hopefully you understand how these two things fit together, right? So we were a bit inspired by these two quotes, so we decided to play around with it and try to solve this problem of listening to our customer at scale. So how did we start, right? We envisioned some steps to success, right? So you need to start, of course. Everything starts with the customer calling us, right? There is a conversation between the customer and our customer service agent. So we are listening to our customer, which makes Richard here quite happy. And as a result of these conversations, we store this data, we store these audio files of these recordings on our side, right? And why do we store this? Because we want to have the data to look into. Traditionally, some companies, they have entire teams of people to listen to these recordings and take notes, right? But this doesn't scale that well. So we want to make Andrew here also happy. So we need to use this data wisely. And the way to use this data wisely is to transcribe this data from audio to text. Here we basically leverage, we thought, why not leverage a machine learning model to transform these audio files, these audio recordings into text. And what's the idea here of transforming these from audio into text? Well, three biggest pillars here. First, once this data is transformed into text, we can run some kind of sentiment analysis, right? So not only we are listening to our customers, but in a really big scale, we are able to find out if they're happy, if they're not happy, and so on, and hopefully find ways to improve that. Second, we can extract, hopefully here, some interesting insights. For example, if we want to check if our customer agent is saying the right words, if the conversation is taking too long, if there is a lot of silence going on in the conversation, we have access to all of these if we have access to the text of the conversations. Well, as a bottom line, we are able to apply to treat these as a quality process, right? And then we can define some KPIs over the text of these conversations, and also find what are the topics that are interesting to the customers the most. Are my customers talking more about credit card? Are my customers talking more about account balance or loans or mortgages? Once we have this text, we have a really, really interesting source of data to answer to all these questions, right? But how to implement this? Well, as you might imagine, this can be quite a daunting process. You don't do these, you don't implement such a complex pipeline from day to night. So we found out about this quite early on. So what we decided to do was to start with a minimum viable product, right? Start simple and just validate if this idea was possible. So how was the approach here? So in terms of the setup, we had some initial components, right? So the customers were calling us. We had an integration with Twilio Twilio is a platform for integration with different types of channels, including phone calls. So this means that we had all these audio conversations stored on Twilio. So we just needed to download them and try to run some kind of machine learning model to transcribe these texts. In terms of the setup, so we set up basically a cron tab job because we wanted to do these on a schedule. And what this job was doing, you have Papermill, which was created by Netflix. And it's basically a way to run Jupyter notebooks as Python scripts. So you can, in this case, what we did was to schedule a daily job, which used to trigger Papermill. Papermill would trigger this Jupyter notebook. Jupyter notebook would start up this Docker container. The machine learning model to transcribe these conversations was packaged in this Docker container. And in this container, we have a TensorFlow model for doing the actual transcription, right? So these are the steps we do here. As a result, we end up with some JSON files. And getting a bit into what kind of output we have from this process. So as I said, we have the text from the conversations, right? So just as an example here, all the individual words from the conversation are part of this JSON file. We know the start and end of each of the words and the probability in terms of the prediction for each of the words. So this got us started in a way we could validate the idea. We could see that it was possible, but of course, there are some challenges associated with this approach, right? So we're talking about a cron type job. So there's no fault tolerance. If anything breaks, you're basically on your own. You're probably going to find out on the next day. There's not really a retry mechanism out of the box. You can implement some workarounds, but it becomes quite complex. Second, it is quite hard to scale. As you might imagine, transcribing audio files is quite a compute-intensive task. If you're talking about running this in a Docker container, even if you run multiple of them in one machine, that is not enough compute, and it becomes a bottleneck. So long time to transcribe if we use this setup. We're talking about on average 6 minutes to transcribe each conversation. So yeah, it's quite a long time. We're also talking about sequential processing. So in this setup, it's not possible to transcribe multiple conversations in parallel. And there's not the idea of task dependencies. I cannot define, for example, I just want to start this task once a previous task is completed, right? So it's not really a good setup. In terms of complexity, well, this is not reusable. If we want to do the same workflow for different languages, you need to implement something all over again. It's quite hard to monitor. There's not the idea of alerts whenever there's any kind of failure. And credentials management, more on the security side, there's not a safe way to store credentials, to access APIs, to access databases, to store this data, and so on. So it becomes quite a limited solution. But then, what is the medicine? How do we solve these problems, right? Well, we decided to start with some ingredients, some basic ingredients. First of all, we decided that Airflow would tackle most of these challenges. It was pretty clear for us. But not only that, we are talking about running a Docker container, and we wanted to run this Docker container at scale. So the idea here was, okay, let's run Airflow on a Kubernetes cluster. We will have a Helm chart so that it becomes easy to deploy this setup. And if you want to deploy multiple times, it's just a matter of point and click. But most importantly, the idea of Kubernetes Pod operators, which is what you can see on the right. So Kubernetes Pod operators, they provide a way for you to orchestrate your Kubernetes cluster, and it's in a quite flexible way. And we found out about it, and we thought, well, this might be a really nice way for us to solve this, right? And just as a recap, when we talk about Kubernetes Pod, what kind of features are interesting here? So I don't know if everyone is familiar with Kubernetes in the audience, but I think what we're more interested here to know is in terms of resources. We're able to define what are the resources in terms of memory and CPU for each of the pods. And we can define what kind of image we want to run in each of the pods. So for example, if I want to run this transcription engine in multiple different Kubernetes pods, it becomes quite easy by following these approach. And Kubernetes Pod Operator from Airflow provides a really easy way to do that. So how did our solution end up in the end? So the idea here is we have a continuous flow of audio files arriving on a synchronous fashion, and these audio files are being stored in an internal network storage. We wanted to define a workflow to process each of these files, but as I said, we wanted to do this in parallel, right? So this is where Kubernetes Pod came in. So we wrote a dynamic tag where one of the parameters is the number of tasks that we want to spin up to transcribe these files. So it becomes quite flexible this way, because if we say, okay, I want to spin up 5 different pods to scale up this process a bit, this means that each pod will split the audio files here, and it's gonna transcribe these files in parallel. So this allows us to get a lot more scale. It can start with 5 different pods, but you can increase even to 100. And the nicest part is that you don't need to change the code for that, because it's a dynamic tag, right? So as soon as I change this parameter from 5 to 100, the next time that the tag is rendered by Airflow, I'm gonna have 100 tasks to transcribe audio files instead of 5. So this is quite powerful. In terms of storage, once we transcribe these files, we need to store them somewhere, right? And the approach we follow here was an ELT approach, so extract, load, and transform. So we basically loaded all of the raw transcriptions into a Postgres database. And once the data is there, we were able to create some interesting transformations and aggregations. As I mentioned, we were able to run sentiment analysis on top of this data to understand the conversation patterns between client and customer service agent, and also to define some kind of KPIs, right? In terms of how long conversations are taking, what kind of words are being mentioned by the client, but also the customer service agent, and how much silence we have in all of these conversations, right? So these became quite powerful and became quite easy to scale using this setup. So what were the results here? Everyone was happy, right? So we were able to make customers happy. Our customer service agents were also happier because they needed to, their work became less intense. And of course, here we are making Richard happy because we're listening to customers at scale. And also Andrew is happy because we're having a really data-centric approach. We're shifting the focus from the model part to the productionization part and the data part. All right. In terms of achievements and takeaways, we talked about data-centric AI in the beginning, and I think the biggest conclusions here are MLOps is quite important. I think we're reaching an era where the model training and the complexity in the code is already kind of a solved problem. You have the idea of transfer learning, pre-trained models, and then you can fine-tune these models. So this is kind of a solved problem. So the problem now and the complexity becomes when it's time to productionize these models. So this is much harder. Most often than not, it's much harder to productionize a machine learning model than to train it. And in this regard, Airflow Kubernetes Pod Operator provided us a quite powerful combination when you couple these with a Kubernetes cluster, Airflow, and whatever kind of task that you want to run that involves containers, right? We were able to achieve great flexibility because we can spin up this cluster up and down, number of pods we can define, we can reduce or increase quite easily. Horizontally and vertically scaling becomes quite easy as well, because horizontally scaling, we're basically talking about increasing the number of tests. Vertical scaling, if we want to improve the specs of our node in Kubernetes, it's also quite doable. The DAGs, they're much more reusable than our previous setup. You can simply use the same code to run the transcription workflow for different kinds of languages. In this case, specifically where we're interested in transcribing Dutch conversations, but also French. And it's quite parameterizable, right? So we're talking about parameters for the number of pods, the number of tasks, but also credentials, access credentials, which is quite important to keep them safely stored. With Airflow secrets, we were able to achieve that. So in terms of future work, just to wrap up, as since I'm conscious of time, we would want to improve the setup in terms of DAG proliferation, right? So I think the next challenge would be to be able to create more reusable DAGs, or a way to orchestrate them more holistically in a way that, okay, I want to run 100 different DAGs for different languages, but I want to use the exact same code base with different parameters. Hugging Face would be nice to export as well. So we're talking about pre-trained models, as I said, and currently for speech recognition, the state-of-the-art models, which were open source by Facebook, they are available in Hugging Face. So basically that means that everyone can go to Hugging Face and download these models. As I said, training is not the most difficult part anymore. We described the batch process, but something that would be quite interesting in this case would be to switch to streaming. And one of the possible ways to do that would be if we have something like Databricks Delta Autoloader, we could set up a streaming job to do these transcriptions in real time. In terms of distributed training and inference, we discussed Hugging Face and that you have a lot of pre-trained models, but when you need to fine-tune some models, it can take a long time to do that, and it can consume a lot of compute resources. So in this scenario, we would want to look into distributed training and inference, and you can achieve that with Spark and Horovod. So some nice ideas in terms of next steps. So this is what I had for today. So I hope you enjoyed it, and I hope it was useful. If you want to keep in touch, this is my LinkedIn profile. I also have this website, this blog, mlopshowto.com. Please make sure to bookmark it and yeah, share your thoughts and keep in touch.